Here are our ideal gas law practice problems. I have the PV equals nRT up top for you and then the different questions down below. Make sure you answer the questions first and then just reference the videos to check your answers. So here we go, starting with question 1. We're just solving for the unknown quantity here. So first, let's go ahead and set up our equation. 1 ATM, so we don't have to make any adjustments to that. It's in ATM already. We don't know our V. And then what you should have done next is set that equal to our n, which is 0.00831. Our r is always the same, and I have it have had 0.08206 right there, and then our t 298, just like that. And then you multiply out the equation, so you have 1.01v equals, and then you go ahead and multiply out the other side, so we have 0.0031 multiplied by 0.006 and then multiplied by 298, and that's going to give you 0.203 right there. And then to solve the question, remember, we just divide by whatever side has the variable on it. So v is over here, so we need to divide by 1.01 on this side and 1.01 on this side. That is going to end up giving us our answer for v. So our volume, the volume you should have gotten for this question, 0.203 divided by 1.01 should end up with 0.20 liters. Volume is always going to be measured in liters, and so that should be the final answer you got for this. If you didn't get it right, go back, recheck it, and attempt. Okay, our second practice problem. You have your second practice problem right here. Go ahead and set up the problem. So again, I have this listed for you up here. Here's the problem right here. Go ahead and attempt it. I will now map it out for you to watch and check your work. All right, we don't know our P, so I'm just going to put P right there. Our V is 0.602. We're going to set that equal to, our N is 0.00801. Our R is 0.08206 as always, and our T is 311. Again, there's no conversions that need to be made because we're already in liters and Kelvin. So on this side we're going to have 0.602 P, set that equal to. On the other side we have 0.00801 multiplied by 0.08206 multiplied by 311, and that is going to give me 0.204, just like that. And then we divide by, of course, the side where the variable still is. So we have the P over here, so that means we needed to divide by 0.602, tab, 0.602 right there. And so that's going to give us our answer, 0.204 divided by 0.602. My answer is going to be, solving for P equals 0.339 atmospheres. Let's put ATM. So that's going to be our pressure for that one. That should be the answer that you got. If you rounded just a little bit differently, that is just fine. But that is going to be our answer, 0.339 atmospheres. All right, we're going to do one more example on this video, one word problem. So first, underline all the numbers we see. So when it says at what temperature, that means this is going to end up being what I'm solving for. So I'm going to go ahead and circle that, because that's what I'm going to solve for. At what temperature would 2.1 moles of gas have a pressure of 1.25 atm in a 25-liter tank? So in this format, so make sure you attempt to solve this first yourself. So go ahead and do that, and then check your work here. So my P, my pressure, equals 1.25 atm. My V equals 25.0 liters, equals 0. And my T, that's my unknown. That's my question mark, because it's at what temperature. So I'm going to go ahead and put it into equation form. P is 1.25, V is 25.0. Set that equal to, my N is 2.10, my R is 0.08, 1.206, and then my T is my unknown. So I'll multiply that out, 1.25 multiplied by 25. That equals 31.25. Set that equal to, we have 2.10 multiplied by 0.08206, and that's going to equal 0.172 T. So then we identify which side has the variable on it. That is this 172, so we're going to divide both sides by 0.172, divided by 0.172, divided by 0.172. That's going to solve the question for us. So we have 31.25 divided by 0.172 is going to be T equals 181.7 Kelvin, always measured in Kelvin when we solve it correctly. So that is going to be the answer that you should have gotten for this question right there, 181.7 Kelvin. So that's our first 3 ideal gas practice problems. There are 3 others on a separate video, so go ahead and check those out for additional guided practice.